Okay, guys. Pull up the right one, hopefully. Here we go. So we're finally putting together the combined gas law. Okay. Let me shut the door. So we've been doing the three laws separately. We practiced each one just step by step. And now all we're going to do is just put these laws together into one big formula. It does the same thing. It just now you can be given more variables and still be able to solve the problem. All right, so a little recap on this right here. Charles' law was volume over temperature, volume 2 over temperature 2. So these are directly proportional, which means if one goes up, the other goes up. So if volume goes up, so does temperature. A way to remember Charles' law versus the other ones, there's a little phrase that says Charlie Brown is on TV, and T and B, so it has volume and temperature. So basically, just so you know, if I ask you just an easy, supposed to be easy question on the test, what does Charles' law deal with? Well, just volume and temperature. And so you remember that by Charlie Brown, Charles' law is on TV, has temperature and volume. For Boyle's law, it was P1V1 equals P2V2, so those are multiplied. They are indirectly proportional, meaning if one goes up, the other goes down. So if my pressure increases, then my volume must have decreased. And how to remember Boyle's law, what it has to deal with, is instead of writing Boyle's like this, like his name, Boyle's, you write Boyle's as in B-O-I-L-S, like a yucky boil on someone, like a boil or a wart. So you say Boyle's have pus and volume, as in they they stick up on a person's body, so they have pus for pressure and volume. It's a little grosser, but that has the P and the V for remembering Boyle's law has pressure and volume. And lastly, Gay-Lussac's law dealt with pressure over temperature, so P2 over T2, and they were also directly proportional, meaning if one goes up, the other goes up. So if pressure goes up, then temperature must have went up as well. To remember Gay-Lussac's law, a cutesy way to remember it is guys like power tools. Power tools. So it has the P and the T for pressure and temperature. Guys like power tools. So there you go, just kind of help you differentiate it. Now, we're going to put all of them together in a combined gas law where we can have all these variables, volume, temperature, and pressure, and still be able to solve the problem. Okay, erasing all this. So the formula for the combined gas law is this. This is the combined gas law where we put all the values together. P1 times V1 divided by T1 equals P2 times V2 divided by T2. And it reminds you over here, it also reminds you that temperature has to be in Kelvin. Okay, so to get your in Kelvin, you take your Celsius plus 273, and that will make it be in Kelvin. Okay, now we just need to do the problem. This is our putting it all together. These last two problems will be the combined gas law. I'm going to rewrite my formula. So I have it here, and it's P1V1 over T1 equals P2V2 over T2. Okay. Now, same thing as before. You're going to have all the variables given to you except one, and you're going to have to solve for that one that you do not have. Okay. So a dry gas has a volume of 235 milliliters. So that's a volume. That's my volume 1 at 15 degrees Celsius. So that's my T1. Remember, I can't use Celsius. So why don't we just go ahead and change it? 15 plus 273 is equal to 288. So it's 288 Kelvin is what I'm actually going to use for my T1. And then and has 784 mmHg. mmHg is one of our pressure units, so that's my P1. So that's my V1, T1, P1. I have this whole set over here. If the volume expands, so it gets bigger and it goes to 600 milliliters, well, that would be my volume 2. And the pressure increases to 1,500 mmHg. So mmHg is the pressure unit. That's my P2. Now you need to check, are they in the same units? In my volume, they're both in milliliters, so we're good. In my pressure, they're both in mmHg, so we're good. And it says, what would be the final temp? So I'm looking for T2. That's what I'm looking for. I'm looking for this one. So I need to figure out how to get T2 by itself. After I figured that out, all I gotta do is solve for it, okay? So over here, it's gonna end up being, I wanna get T2 by itself. So if T2 is being divided right now, to move it to the other side, or I can move those to the other side. I guess it'd be easier. No, it's easier this way. So we're gonna multiply T2 up here. Okay, so it's gonna cancel it, and that'll make T2 be up here, okay? It's still not by itself, so we're still not done. And then, to get it, I'm trying to get it by itself, so I'm gonna have to multiply it. To get rid of this, I'm gonna have to multiply it over. So I'm gonna multiply T1 over here, multiply T1 over here, and that cancels it. So now it's gone, okay? And then I still have to get rid of P1 and V1. So P1 and V1 are being multiplied together, so to get rid of them, I have to divide by P1 and V1. So now they're gonna be gone, but it's gonna be divided over here, P1 and V1. Now I know that got very chaotic, so I'm gonna circle what ended up being over here. T2 is what's left over here, everything else has been canceled. That's why we want it to be by itself. Over here, we have P2 and V2 still on top. They're multiplied by T1, because it's on top, and they're divided by P1, V1, because they were being divided by. So let's rewrite this whole big chaotic mess, all right, as what it actually ended up being. It's ended up being T2 is equal to P2 times V2 times T1 is over P1, V1. Okay, so basically the hardest part is just moving the variables over correctly. I'm gonna walk through each one in class. Like I'll probably help set up the worksheet today to show you how to get that one by itself. So if you're struggling after these two examples, please join the Google Meet today to help on your worksheet. All right, so this is our new formula. Now we just gotta plug and chug, plug things in and solve it. So P2, okay, well my P2 was this one. So I have 1500 mmHg times V2, my V2 is over here. So it'd be 600 milliliters times T1. Well, T1 was the one we had to convert, the 288 Kelvin. So those are all going to be multiplied together, and they're divided by P1. P1 was over here, 784 mmHg times V1. And V1 was 235, right here, 235 milliliters. Okay, that will equal T2 when I solve for this. Now watch how the units cancel. mmHg are on top of each other, so those units are gone. Milliliters are on top of each other, so they're gone. And the only unit that is left is Kelvin. I'm gonna kind of scooch this over. Okay, so is Kelvin. That's the unit that I'm left with, which is a temperature unit, which they asked me for final temp. So I must be on the right track because all my proper units canceled themselves out and I'm just left with Kelvin. It's kind of how you check yourself if you set up your problem right, was do all my correct units that I needed to cancel. All right, now just plug in the calculator. So I take 1500 multiplied by 600, multiplied by 288, hit enter. And then I divide, but see, these are multiplied by each other. So to do this correctly, I'm gonna have to divide by a parentheses set, 784 times 235, close my parentheses set. So the reason why I put the parentheses around them in the problem is because they are important. They need to be in parentheses or the calculator won't know which one to divide first. And the answer is 1406 Kelvin. And actually that rounded up to 1407 Kelvin. And there we go. So that is how we do one of the problems. We solved it. Yay, there we go. All right, let's try to do one more. Let's try to do another example. Okay. So same thing. We have, make sure I write it right. So I have P1 times V1 over T1 is equal to P2 times V2 over T2. So that's my original combined gas law formula. And now we're going to see what we have. So we have a quantity of dry gas has a volume of 1.25 liters. So that's my volume 1. Okay, so I have a volume of 1.25 liters. A temperature, because Celsius is temperature. So I have a T1 of this. But remember, I can't have it in Celsius. So I'm going to have to change this to Kelvin. All you do to change it to Kelvin is add that 273. Well, this is an easy math. 100 plus 273 would be 373. So really what I'm going to use is 373 Kelvin. And 880 mmHg, so that's my pressure, so that's my P1. So I have my T1, I have my V1, and I have my P1. Let me rewrite that, so it actually looks like V1. Okay? What would be the volume? So I'm looking for V2. That's the question. I'm looking for volume at STP. So STP means standard temperature and pressure. So standard temperature and pressure, you can Google, but standard temp is 273 Kelvin. That's just standard temp. You Google it if you don't have it, but that's what it is. That's standard temp. And standard pressure is 1 atm. But a little problem here, this is mmHg and this is an atm. So those are in different units. So before I can use one of them, I'm gonna have to turn either the mmHg to atm or the atm to mmHg. It doesn't matter, they just have to match. So if we go back to our original conversion problems from the very first day of these, it tells you how they relate. For every 1 atm, there's 760 mmHg. So it's a really easy problem. I put ATM here, I put mmHg here, so I'm going to convert it into mmHg. For every 1 ATM, there's 760 mmHg. How do you know that? It's on the first page of notes. It tells you how they relate, okay? So now ATM cancels, and 1 times 760 is still 760 mmHg. So my standard pressure is this. So this is my P2. This is my V2 for my, not V2, my T2. Like that, that's my T2. So what I'm missing is volume, my volume 2. Okay, so I'm going to circle the one that's missing. The one that's missing is this. All right, so I need to get that one by itself, volume 2. Now, how do I do that? I'm going to start the same way as I did last time. I'm going to get rid of this one. So it's being divided, it's on the bottom. So to move it over, do the opposite, which is multiplying. So I'm going to multiply by T2. That cancels it over here, and it gets put over here. Multiplied by T2. Okay. Now I got to get rid of this pressure value. Well, P2 is being multiplied with volume 2. So to get it off of each other, you have to do the opposite. So the opposite of multiplication is division. So now I'm going to divide by P2. So now it's gone over here. And I'm going to divide by P2 over here. So this is a little less chaotic looking than before. So as you can see, the only thing that is left standing is the volume 2. Everything else has been canceled. So I'm just going to kind of leave it here and erase it. A little easier to do in this version. And it has V2 by itself is equal to T2 times P1 times V1 divided by P2 times T1. And there we go. That is our new formula. And now we just plug in our numbers till we get volume 2. All right, so it says T2. So T2, that was the standard pressure. So it went to standard temperature. So standard temperature is 73K. Multiplied by P1, okay? So the first pressure they gave me was this one. So I have 880 gosh, I just got all wrong. 880 mmHg, okay? Times V1, this kind of got in the way. Okay, so times V1, which the first volume they gave me was 1.25 liter. Okay, and that's all going to be divided by P2. P2 is the one we had to get in mmHg. So our pressure 2 was 760 mmHg times our T1, or temperature 1, which was this one. We had to go from 100, we added 273, so it's 373 Kelvin. Okay, now let's check our units here. Kelvin's on top of Kelvin, those cancel. mmHg is on top of mmHg, so those cancel. Liters doesn't cancel. Liters is a volume unit, and that's what they want me to get to. They're asking me for what's the volume at standard temperature and pressure. So we've done it right. We just got to put these things in the calculator correctly, which means parentheses. So I take parentheses 273. Make sure you put in parentheses 273 times 880 times 1.25, close parentheses set, divided by new parentheses set, 760 times 373, close parentheses, hit enter. And my answer in liters is 1.06. Okay, there you go. That's how you solve those. So it's really the same. It's just you're having to maneuver the formula a bit more. If you need help, join the Google Meet.